All right, let's do an example here where we're going to identify vertical asymptotes. And so now, just to recap, remember what we're going to look at is we're only looking at the denominator. Okay? In other words, another way to look at this is we're looking for all of the restricted values of each of these rational functions. Remember, when we talk about rational functions, the restricted values of the domain are all of the values that make the denominator 0. Well, it turns out that those values, those restricted values, also correspond to vertical asymptotes for the graph of the rational function. So that's what we're going to look for. So now in this case here for part A, again, all we're going to look at is the denominator. So the denominator is x minus 3. So all we have to do is find the value that makes the denominator 0. So what value of x will make this equal to 0? The answer is 3, right? So all we're really doing is taking the denominator and setting it equal to 0, right? So the value of x that will make this 0 is 3. So x equals 3 is a vertical asymptote. Okay? So x equals 3 is a vertical asymptote. Okay, now what about b? G of x has this polynomial in the denominator. So again, we would just set that equal to 0. Now, the first thing that we want to do is see if this thing is factorable, right? Okay? The worst case scenario is if it isn't factorable, then we can use what? The quadratic formula. Now, remember, we're only looking for real zeros of the denominator. So we're not looking for complex zeros, okay? So in this case here, if it's not factorable, then there are no vertical asymptotes, okay? Well, no, let me rephrase that. If we can still use the quadratic formula. So if the quadratic formula, worst case scenario, it could, if we get a real value, it could be a square root of 3 or square root of 2. But if we could get a real value, then we have a vertical asymptote. But if we end up with a complex root, then we ignore it, okay? Because then there would not be a vertical asymptote there. Okay, so let's look at factoring this. Okay, again, if we use the AC method, right? So we find the product of 3 and negative 2, which is negative 6. We look for 2 factors of negative 6. Then when we add them, we get a positive 5. And so obviously that's going to be what? It's going to be 6 and negative 1, right? 6 and negative 1 will do that. So then, of course, we can use our method of decomposition, the AC method or method of decomposition, right? So then we're going to rewrite this as 3x squared plus 6x minus x minus 2 is equal to 0. Right? Now we can use factor by grouping now that we've decomposed the middle term. Okay? We can now factor by grouping, which is going to give us this, right? And then plus that. Okay, now I'm going to factor this part, which is going to give me 3x times x plus 2. And then I'm going to factor out a negative 1 here, so minus x plus 2 is equal to 0. And now I'm going to factor again. Now I've got a common factor, I'm going to factor again, so I'm going to pull out the x plus 2, and that leaves me 3x minus 1 is equal to 0. Now I can use the zero product principle, and I find that there is what? There's an asymptote at negative 2. So at x equals negative 2 is a vertical asymptote. And now if I solve this one equal to 0, I get 1/3, right? So x equals 1/3 is also a vertical asymptote. All right, good. Now part C. Now part C, if we look at the denominator, we have a sum of 2 squares, okay? So in this case here, there is no real solution to this. There's nothing that we could put into x that is going to make this thing 0. Because anything we stick into for x will end up being positive. Okay, so therefore there is no real solution. So there is no vertical asymptote for the graph of k of x. And that's it. It's that easy. Practice.